Arun, we have most of the students from the S2 batch, no?
Yes, sir.
Yeah. Okay, that's
Yeah.
good. And S4?
S4 is also there, but majority, more than 50% is from
Okay. It's good enough. That means you have around 3 to 4 years ahead of you in your education, your technical education, and what I say now will become ripe at the time of exit from the college. So I'll be talking in a rather futuristic manner as well as touching the present. So in those olden days, no, when I was my senior and the founder director, Mr. Sham, is moderating the show along with Ananta. So he was my senior in instrumentation department in Bokaro Steel Plant, and there I used to be guided by him, and I was mostly in the lab, in the instrumentation lab. And those days, I just want to recollect for a few minutes. Those days we had to work very hard, with real hard labor, that is soldering, changing components, etc., for designing and modifying a circuit, and also for testing it. And when the device is sent to the field, what happens is that if something goes wrong, we just have to call it back or go there and use a Towers International manual or some other manuals available to find out the problem and troubleshoot. Boys and girls, though gone are those days with the advent of IoT and related technology. Here, now we can, sitting at home, you can interact with a device and upgrade the device, change the gain, etc., through technologies like FOTA, that is firmware over the air, and over the air firmware updates. So that's how things are. So we are lucky, Sham, me, Ananta, we are lucky to be a part of the changing technology. So it will be a big tour for you. Now let me open a nice presentation for you so that we can go ahead. So let's see where the presentation is. Okay, here goes. Okay, so let me make it a full screen show. Slideshow full screen. Okay, there you are. I hope the screen is visible. Okay,
Yes,
Yes, sir.
Ajit sir.
very good. So this is what it is. The stack of the IoT will be explained and its industrial applications with certain case studies. Now, the agenda for these 2 days, coming days, it is only a part one of the program because I have got got enough stuff to speak for hours together. That is 8 or 9 hours. But I'm limiting it to 4 hours, 2 hours each. One set of 2 hours today and another set of 2 hours tomorrow, and maybe part two where you come to the ground level and really as students will give you an opportunity to what are the tools and tackles required to become a part of IoT in the next 3 to 4 years. So the current program, that's part one. I'll just tell you what it is about, how it evolved, how it works, the IoT works, and the current status and future prospects of IoT in the current industrial scenario of 4.0 and 5.0. Definitely, I'll tell you what 4.0 and 5.0 is. It is very interesting. It is a sea change away from those Bokaro steel plant, those days in the 90s, when industry level was maybe 3.0. Then we'll look at various applications of IoT with some detailed study on cybersecurity. Okay. Then tomorrow we will find ourselves discussing on various real life case studies. One of them, two of them are the smart city initiative. One is a cloud-based enforcement system for traffic that was done in the Netherlands, Holland, and then another one in India and part of it in UK called intelligent fleet management systems. That also is a part of a smart city initiative. Then cloud-enabled or rather web-enabled remote display systems, where how we can develop a system by which you can update from a mobile app some information to a screen which is placed far away, maybe outside your country itself. Then we come across the intelligence in insurance. Gone are those days when you have to, carry paper covered files as insurance or a card. Now it's all in the cloud, and the insurance amount, the premium will change as per your driving habits, how you maintain your car, etc. So that a good driver have lower premium to pay. So in addition, it will be promoting a safer roads and a greener environment because it takes care of the car maintenance also. Then the advent of LoRa and BLE has proved to be a boon to the already congested internet networks. How it is used in a certain specific application and in parking is also to be shown. And tomorrow I may bring a guest from the smart city itself. His name is Prosenjit from West Bengal, who was my junior in the project manager in the Surat City Corporation city project, I mean smart city project. I just sent out a request to him and waiting for his confirmation. So just to have a um, uh, real life situation, or right to hear it straight from the horse's mouth to some extent. Okay. Now, what is there in the part two of this program? The part two will cover your skill sets that you require. First time I'll tell you the whole story, what it is and what it is not. Then I'll go to the skill set in the IoT domain. Uh, then the IoT lab, how you can set up an IoT lab in your college, which will be very useful. It is a thought for the future. Then the various SBCs. You know anybody what an SBC means? Any of you? SBC? It stands for single board computers. We have seen computers as desktops and laptops, but there is in a board also that computer is possible. That is very much used in IoT development. Okay, I'll explain and compare a few SBCs. Then on day two of the part two program, we'll be looking at the various IoT platforms which beginners can use. There are, I think I have listed on 8 or 9 of them. Then how this machine learning, AI, artificial intelligence, and deep learning concepts are applied in IIoT. Then what are the challenges in the IoT domain? And of course, your most interesting point would be how you can get employed in the IoT sector. To tell you frankly, IoT is just not the um, the baby of electronics, computer science, even many disciplines. It's a multidisciplinary area where it's a typical case where many, even mechanical, civil, in smart cities, of course, and electrical and computer science engineers come together for a common cause. So it belongs to the engineering fraternity as such. Okay. Now, uh, in this employment part, I just tell you, I just briefly touch upon that also in this session also. Now, let us slightly speed up. So, since the introduction is over, so we have running with a tight schedule. Just to explain what IoT is. So, it's nothing but a network of devices along with computers existing. So far, you have thought of only computers, desktops, palm tops, and laptops in an internet network, or intranet or internet network. But now we are adding objects also, physical objects and things like a process instrument, a display device, a tracking device, and in the lighter extent, air conditioners, washing machines, etc. Like you may be knowing that nowadays we have, you know, smart homes, smart things by LG and Panasonic, where these even air conditioners are intelligent and controlled through IoT stack. But our view would be from the industrial engineering point of view, and hence won't be talking much about the domestic aspects. So, what is IoT? It is a network of physical objects or things embedded with electronic circuits, software, firmware, sensors, and with proper network connectivity, and which makes these objects talk to each other and also to the computer. And it will have certain communication and control protocols. Okay. Now, what are these things? I told you already what things are. They can be anything from a heart monitoring device to an instrumentation equipment, a biomedical implant, some biochip transducers, MEMS. MEMS are small chips, electromechanical systems. Micro electromechanical systems is what MEMS is. Electronics engineers would have studied it. Then in automobiles, the world is talking about autonomous cars, which are driverless cars, which can navigate through the terrain without the aid of a driver. Then controller area networks and built-in sensors are part of the IoT stack in a car, and in firefighting and various other search and rescue operations, as you have seen in the present day crisis. Then it all happened with this Kevin Ashton, who first named it. See, for anything and everything, you need somebody to name it. Now, the naming ceremony was done by Kevin Ashton way back in '99. At that time, I was in the Bokaro Steel Plant along with Sham. Those times we heard of it, but it was just a name, a naming ceremony. It existed a little ahead of that also, maybe in the late '90s. So, but a name had to be given, and he gave the name, and he gave it when he was working with RFID signals, sensors in a supply chain management environment. So, just how it happened. Kevin Ashton, he is a British technocrat belonging to Birmingham in north of London, and he named this as IoT, okay, Internet of Things. And how does it work? Very good question. How it works? I have a small hand sketch to explain things in a very clear way. So now you see the cloud here as the center of the show. The cloud. You are very almost all of you will know about the cloud. The cloud is helping us to meet now. No, even this process of talking to you is a part of cloud computing in itself, because my colleagues are sitting in different parts of the globe, and I am speaking to you just 10 kilometers or 15 kilometers away, at least some of you, in the same city corporation of Thiruvananthapuram. But others are far away, but we are connecting. There are fallback plans also. If something goes wrong with the presentation, it will come up from somewhere else. That's a part of the cloud management. So that's a cloud as a center. Okay. Now, before the cloud, we have to feed it. Now, we have to feed the cloud. The cloud has to be fed. What will you feed it with, students? You have to feed it with a proper signal. Not only a signal, you have to analyze the signal and give only the wisdom, not the information, only the wisdom. So, what is the wisdom? How it comes from? Let's look at it. These things, as I've told you already, these are the things. That is the process instrumentation devices, automobiles, various display systems, MEMS devices. Those are implants. Then wearable electronics, as you see, some of you would be wearing this pedometer and all that for your health analysis. Then household appliances like air conditioners, washing machines, etc. They are the things, and we need to build smartness to that. Some of them may be built smart, they may be born smart. If those of them who are not born smart, we need to have a transduction done from their physical parameters to an electronic signal. In instrumentation, would be a 40 20 milliampere DC signal, and maybe or 1 to 5 volts. And now the output has to be streamlined using the smart tech to connect to the internet. So basically, there will be a lot of components in that, electronic components in that, which converts this thing and makes it talk to the communication module. And that as a communication module, what do we have? We have the GSM, which goes into your mobile, the local area networks, highway addressable remote protocol transducers, that is for the instrumentation communication between devices, between various process control devices. Then Wi-Fi and Zigbee. Zigbee is just a glorification of Bluetooth, where the signal travels by cascading. Okay, and then when all the signals are in place in the cloud, we have a web user interface here. The application layer it is called, which I'll explain. So what does the application layer do? It communicates with the cloud and acts on the cloud, and it's a two-way communication. Actually, it will be a two-way communication, as you see here, an arrow here and arrow here. That is, cloud takes data, gives back data, and gives back control also. So, friends, please don't think that IoT is just gathering information remotely. It is not only gathering, it is analyzing the information, taking corrective action without human intervention. Okay, so let us proceed with a more holistic view of the stack, as you see here. We have at the core architecture, we have the devices, as I told you, then the gateway, which was explained just now, the gateway which The device, you know what it does. It is written here also. The various devices which communicates with that, with the gateway. That is where finally it has reached the cloud. The data will be acquisitioned as an electrical signal. I told you just now. These are typically systems that contain embedded sensors that collect data. Okay, they will have embedded sensors or the smart tech to convert it to get to imbibe smartness in that, to imbibe smartness in. I don't know. I'm okay with the speed and audibility and visibility. I don't.
Yes, sir. Yes, sir.
Give a
It's fine.
keep
Fine.
give me a routine feedback so that so that I don't
Sure.
feel like I'm talking to a wall. Okay.
Okay. Okay.
So things are clear so far, I think. We have a lot of things to go. Slowly, I have to accelerate. Okay.
Yes.
Arun, a lot
Yes,
of
sir.
things to cover. Okay. Okay, right. So gateway. We'll go to the gateway now. What is this gateway? I made a small hand sketch here. So IoT gateway is simply making the devices communicate to the network. There are two types of networks. One is intranet, connecting the various devices together at the ground level, and internet, which takes it to the cloud. So here, happens to the gateway tier? It routes data and manages the traffic. On one side, what we have? The intranet, the small gateways. It could be an I2C or it could be a PCI, could be anything. Any of those embedded routes. Okay. And on the other side, we have the gateway. So it is the interface between the network and the sensors. Sensors are also connected through various networks because we are not talking about one sensor. It's like the LAN connecting to the internet through the router. Okay, so they are like data switches. It collects and homogenizes the streams into manageable data and deals with the complexity to connect the different devices and the data streams. Now, what about the data tier? The different gateways, the data is collected and managed. And depending on the type of data, there are basically four types depending on the volume, the variety, velocity, and veracity. Veracity is nothing but the integrity of the data, that is the truth of the data or the correctness of the data. That's veracity. So there are four V's in data. These are the four V's: volume, the amount; variety, that's what type of data is encrypted or unencrypted; and then velocity. Velocity means at what rate gets updated. Depends upon the application. Okay.
Okay.
Yeah. Right. Good. Thank you. Then the data analytics. Data without analytics is of no use, I should say. Just knowing many things. For example, students, if you read so many books on IoT, it may so happen that nothing may stick to your mind unless you derive wisdom from it. How do you derive wisdom from it? By analyzing and removing and filtering the data. So data analytics basically does that. What does it do? It filters data. It automates the process manageability and speed. As there are multiple type of heterogeneous mixture of devices, there will be more demand on data analytics. It makes things simple by doing protocol translations, provide security, and will add the interface for data input and output. It can be used also for the ongoing analytics and can also be stored for the future. Then application tier, it's the basic tier or the control panel, which most of you are familiar with if you have worked with IoT devices like air conditioners, washing machines, etc. Most of you, it's a layman's layer where you do the controls remotely. And what does it do? It also there are two applications. Application tier is a tier which controls the IoT stack. That is, the ground level devices are controlled through instructions from the application tier, and those instructions are made not in a technical way, in a layman friendly way. Like it will be on a soft key buttons, like in an air conditioner. You will have a temperature button or the actual temperature. You press the up button, the temperature goes up, and if you press the down button, temperature goes down. So we need not know anything about the technology behind it. Okay, so that's the application layer is interface with the human beings. Interface with the human beings. Okay.
Okay.
Now at the same time, the application layer will also be used like in smart cities, etc. to define and derive key performance indices of the what should I say of the front end officers, the front end executives who run the application tier or the control panel. So the two-way application tier runs the show. Mostly it is automated for any control from the plant of the from the point of view of the operator. He can do that using application tier. Secondly, to monitor the work progress and the efficiency of the staff involved, again the application tier will come into play when we push third-party software for knowing the key performance indices and various aspects like that. Okay. Now, where do we stand in terms of IoT? Let us look at it. In the world that has gone by, 2003, we had only 6 billion people and around 500 million, billion, 6.3 billion, and only 500 million connected devices. And slowly, somewhere in 2006-7, we started having more connected devices than people, and around 4 per person was there in 2015, and now we have around 6 to 7 per person. In these connected devices includes all IoT enabled devices, including that given from office also for the technocrats. Okay. Now, by 2030, what happens is the human machine interface will start functioning. Around 40% of the current workforce will get replaced by technology. That doesn't mean that the people will lose jobs. I'll explain that in the as we discuss. AI chipsets market, 83% will be controlled by IoT stack, and the IoT devices market can touch around 26.2 billion, and 50% of organizations, more than that, will be leveraging AI technology for networking. How this AI, machine learning, deep learning, etc., related to IoT will be explained to you as we proceed. So, students, we need to gear up to meet this eventuality. So, I hope that all of you will give a careful listening ear to this, so that there will be some good takeaways from you. Some of you I'll be happy if at the end of this part one and part two, I hope that I'll be able to create some good IoT and robotics engineers. Okay, that would be a great, not only for me but for the whole TNC team. It will be a great satisfaction, I should say. Okay, now what are the advantages in the case of production? Advantages means of IoT implementation. So what will happen is in maintenance, plant and machinery maintenance, predictive maintenance will take over preventive maintenance with the help of IoT. What is this preventive maintenance? Preventive maintenance are maintenance schedules that are published on a certain routine basis. For example, for a machine, it may be changing the oil on every third quarter, then changing the gearbox, maybe not changing the gearbox, so changing a gear wheel every 6 months, like that. The technician will be forced to change it, even if there will be no what should I say, no problem or fault, because it is written in the preventive maintenance chart. So in predictive maintenance, we have sensors looking at the various IoT stack. Through the IoT stack, we look at the various key parameters of, for example, a motor, the vibration, the oil level, etc., and we'll do feed forward action. Before a breakdown happens, these things will be corrected at the next point of shutdown. We'll discuss it later in further. Then providing product as a service is possible through IoT. For example, the air conditioner, if you give it, if you sell it, normally in the olden days it was just forgetting after selling. Now what happens? You can the product manufacturer can do it as a service also. For example, more functions like you know electricity consumption, then online maintenance, online remote maintenance of this can be enabled at a higher cost through IoT stack if it is an IoT enabled AC. Then data analytics will be possible, user friendly interfaces, software updates. You want to have a updated AC, you can do it over the air. You don't have to like the olden days, remove a board and put a new board, new PCB. Then inventory and spare management becomes so easy now with IoT. Reconditioning and repair actions become possible. Remote monitoring of assets is possible. We'll see it as we progress. And healthcare industry gets redefined. How? I'll show you in a bit. Now this is the learning curve, or rather the prediction curve of the various technologies that are growing, and IoT is one among them. And IoT is one of the successfully incubated technologies. And so many technologies came up, like a neuro business, then organ transplant, smart advice, etc. But what have survived is just these 30 of them. These are 30 survived, or rather, who are the watchouts for the next 10 years. There's a period when you land in the industry. That's AI is one of them. AI, then IoT is one among them. So is a second rank holder is IoT in the among the 30 technologies that are coming up. So good that we are discussing on IoT. And this IoT is here and is in many other places also, like in energy tech. For energy management also we need IoT. Then cybersecurity is needed by IoT. Voice assistance. All these are the new technologies that come up and they are interrelated. IoT has a role to play in almost all cases. Okay, in 3D printing. Okay, nanotechnology. And then many touch interfaces. New displays are coming up like electrophoretic displays. They're called e-paper, etc. Then mobile technologies, cloud computing, blockchain, big data. Then geospatial tech that I'll explain about geospatial tech also in one case study where we do tracking. Human computer interaction, that is the fifth generation. Industry 5 will be explained to you. So just take it in mind that a few of them or 30 of them are the technologies of the future. And we are talking about the second highest technology that is currently growing and growing at an exponential rate. Okay, now just a sec. Now, what about IoT? Among the various 30 technologies, IoT has itself an acceleration curve. We are reaching Industry 5.0 with a physical world web and software agents and advanced sensor fusion, starting with just RFID tags in the days of Kevin Eston when he invented the term. He invented only the term, not the exact technology. And it went on with nowadays we are talking about tele-tracking, which is the order of the day. Many of your college and in the college buses even have tele-tracking, remote tracking, vehicle tracking, etc. Now, with the advent of electronics, like Mr. Moore is one of the co-founders of Intel, has told that the transistors, the embedding transistors in a chip, it gets doubled over a period of 1 or 2 years. So the VLSI designs, very large scale integration designs, are increasing. So is the case of various IoT related technologies. Like even this book I had now during my college days when along with Sham I was studying in for MTech. It was there in the 90s. It took a hibernation called AI winter because other technologies were not developed to that extent that we can use IoT to the maximum. Nowadays, that's not the case. Technologies have advanced, computing technologies, the embedded systems have come up. So, those days, when we had to wait for hours to get the result of a processing, we feed it for processing in the computer and we wait for the whole day to get a result. Now it is possible in a few milliseconds. Okay. Now, just for familiarity, there's a term called the Internet of Everything. What is it? Because you should know the present term is IOE and IoT are interchanged. IOE means it involves people also. As we are walking towards Industry 5.0, it is highly likely that the IoT term may get replaced by IoT, IOE. IOE, which stands for Internet of Everything, which includes people also. But because Internet of people can never be transplanted or substituted. So we have P to people to machine, P2M, P2P, people to people communication. The IOE concept, people become the central role. and they get connected themselves also, like in medical professionals. Okay, this is penetrating many fields like manufacturing, information, retail, finance and insurance, healthcare, etc. So IU is extending everywhere and has unlimited possibilities. Now let us look at the industrial applications of IoT. Now the new normal is disruption of technology. Once you start doing something, it happens with you students also. You start learning throughout this 4-year course on various systems like embedded systems also. You may be learning one controller, say PIC 16F866 is what you will learn. But there is now 32-bit PIC microcontrollers are available. Another one may come up the next few months. So technology is growing at the rate of electronics is growing at the rate of 4 to 6 months or even bi-monthly basis. So your academic syllabus gets updated only once in 5 years. So you have to live with disruption and read further and attend sessions like what we are doing now, so that you get updated. Because whatever I'm talking to you, to read all that may take you months, because it's from the experience of working with these systems, and touching them, working with them, learning failures, getting shouted at by the bosses for things not working, which may be of no fault of mine, like that. So all these things is words of wisdom, from me and my colleagues and people like us who have around 30 plus years of in the industry. You should learn from them, which will be a catalyst, an adrenaline shift in the studies. Okay, and now the exponential technical progress, how I'll just show you. So students, you have to decide whether the technology should be driving you or you will be driving the technology. The change, you should be driving the change rather than you get driven by it. If you don't drive the change, take it from me, you will be driven by it. You'll be forced to take up some job which may not be of your choice. If you don't specialize in something like IoT, AI, machine learning, or something like that, then the changes will drive you. You'll be forced to do something. Forced to, because there is a gap between demand and supply. No, that's what I'm trying to say. I think I'm making it clear. No, Arun is
Yes,
there.
sir. Yes, sir. Yes.
Yeah, yeah. Okay, okay. Now let us say the evolution. I was talking about Arun. Okay, Arun. I was talking about the exponential growth, the disruption. It is how it happened. For changing from mechanical engineering streams like mechanical systems like water power, steam power, and weaving loom, which works on steam only for mechanical devices. Now, what has happened? It took around 100 years, it's around 100 years, around 90 years to change to bring electrical energy into the system. So, electrical industry started in 2.0, industry 2.0, that is in 1 century was there, when one generation gap was there. Then came Industry 3.0 with automation, computers, and electronics. Electronics, computers, and automation, many other things. So, what happened? That took again another 100 years, 99 years it took. 99 years. Again, one generation went by. And here, this is like, the engineers like me, Sham, etc., were in this era. So, we are the lucky ones who have seen the transformation of technology. That is 3.0 happened. I mean, we were born that time. Then when 4.0 is where we were till now, with physical systems, IoT, etc., just growing. And now 5.0 is co-working. I'll explain what co-working is. That is, just bear with me a little bit. We'll go to that. So what happens is an exponential growth in electronics engineering domains, and not only in electronics, in all domains. Electronics is driving all engineering aspects, civil, mechanical, everywhere. Electronics is driving it. Like electrical has become electrical and electronic. Civil, there are various this GPS related topics for geo mapping, etc. Mechanical, we have mechatronics. Everywhere it is there. And in computer science engineering, we have this embedded systems and IoT, which are hybrid varieties of both. Everything that used to be dumb and disconnected, like The people of my generation know. Even Arun may know that in the early days, Arun was running around with floppy diskettes,
Yes.
AMKET make. Earlier it was a flat, large one. Then it became a diskette type for 1.3, 1.2 MB of data, changing from say data of 50 MB from one computer to the other. He had to do say 10 or 20 trips up and down to, you know, or take a basket full of floppies and name it 1, 2, 3, 4 like that, and do the same process at the other computer itself. Now that has changed. Everything is now wired and intelligent. Wired means I include wireless also. Then the new nervous system is the IoT. And what is the oil? AI, this artificial intelligence is actually the oil. And IoT is a new nervous system. I'm sorry, AI, artificial intelligence is the new electricity, I should say. AI is the new electricity. And data is the fuel, the oil. And IoT is the connectivity, the nervous connectivity or the nervous system. Okay. And we have cobots instead of robots. And what are cobots? Just bear with me a little bit. We'll see what it is. And 4.0 is migrating to 5.0. And you just see here and all it took 100 years. And here also it's only 50 years. And here it's just 7 years. Where is 7 compared to 100 here? Just imagine the rate of growth. And you students are at the epitome of this rate of growth. So you have to keep abreast with the technology so that you'll be able to answer all the campus selection questions from the various firms in the business. Now, the industry sector, many manufacturers and process industries, including healthcare, are embracing IoT for their business. They are leveraging data taken from machines and appliances and moving, as I said earlier, from selling a product to selling a product as a service. So I hope our students got the concept. There is product and product as a service. Product non IoT days. You have sold it and you have no access to it now. It is with the owner. Any change you need to do, for example, the old TV, the conventional non-smart TV. If you want to add something like you want to have this HDMI input, either you have to buy a module, a converter module, or you have to change the motherboard. Now such facilities are now available over the air by updation, and for that the manufacturer can charge you a amount without actually visiting you or without touching the device through over the air firmware updation. That happens in smart Android TVs, etc. Okay.
Okay.
Now the resulting value added services like monitoring it all the time 24 by 7 in the actual real time. Then I told you remote troubleshooting, just I mentioned it. All these things will keep you abreast of the competition and help you to sustain the business in troubled waters as we are facing now. Then investment in this IoT driven capabilities can increase the customer loyalty, as now IoT driven appliances are still being serviced because even in COVID areas and contained areas, only IoT driven stacks can reach. Like something has to be updated, over the air updation can be given. Some reset can be done remotely. But for analog non IoT devices, they are still in the backyard waiting to get repaired by a physical visit. So it is a radical transformation, and IoT platforms are changing the structure of the industry, which I'll explain you just now. And where are I just briefly touch upon with the advent of it. If you embrace IoT, you can land up in telecommunication organizations. You can be a self-entrepreneur, start your own as I think I don't. You have a lot of plans there, no, for
Yes, sir.
entrepreneurship.
Yes, sir.
Yeah, yeah. I
Actually,
think
we have this
I mean
innovation and entrepreneurship center.
yeah, yeah.
Yeah.
Exactly. We are talking about that subject only now. And
Yeah.
smart city projects, very interesting projects are there where a plethora of disciplines. mechanical, civil, electrical, electronics, computer science, IT, everybody work together in a smart city. Okay. Then robotics projects, then manufacturing services, electronic manufacturing services. Even agriculture is not spared by IoT. Just imagine, students, you buy a farm in Kanyakumari district or in Tamil Nadu where land is cheaper than Kerala. You buy 1 acre of land at 10% of the price of land in Kerala. You want to cultivate it. Now, IoT will help you to cultivate it by remotely irrigating it, remotely knowing whether there are rodents and how is the health of the plant, etc. By exactly by how this Japanese guy is doing. Only thing is you go there and set it up. Either you do it yourself or get it done. Once it is done, then this cloud will control it through you. The control panel will be with you in Trivandrum, and that will be 100 kilometers away. I hope the point is driven home. Then R&D works. Beautiful scopes are there because everything is going to be discovered now. And healthcare and biomedical instrumentation. Wait a little bit. We are coming to that. Then how is it transforming? That is, how is the evolution? 1.0, I told you steam power, then goes on like that. Now I'm just showing it again just to know that we'll be starting somewhere here now, 4.0, where we have this IoT and computing networks, and then co-working means machine and the computer working together. Like you and your friend would be a robot, a cobot actually. Okay, that is now happening. You can see the shake hand here now, a robot shaking hand with a human being. Now let us look at 4.0 first. So what is this 4.0? 4.0 is nothing but a congruence of the existing technologies like robotics, cloud computing, 3D printing, artificial intelligence, big data, and all that, value chain and various sensors. So what happens is that these algorithms we are used direct, for example, motor vehicles, including navigation tools as everything, and embedding all of them in elements in a manner that will increase the your reach. Like we are Sham, we are doing a project in IoT. I mean, we may be developing one part will be developed here, the other part in US, and other part in Japan. That's what we are doing. Everything will be accumulated. The pandemic is not stopping us in developing an IoT stack and even selling it. That is the concept of 4.0. Okay, the robotics and artificial intelligence, I described that, and this explains it in a better way. That what makes industry 4.0. What is it? Just have a look at the whole picture. We have IoT at the center. You see, industrial IoT at the center. So Industry 4.0, what does it conceive? It conceives smart systems and smart engineering. On one side, we have cloud computing, which is more related to computer science engineers, and then cyber physical systems on the other side. Then we have the industrial IoT at the center where we are now. And what happens in that? What are the things in that? The IoT platforms. And in part two, students, I'll be explaining around 8 platforms and evaluating them and benchmarking one against each other. It is for the IoT beginners, and we'll also discussing how to set up an IoT lab. Then in industrial IoT, we have mobile devices, augmented reality. I don't know, I want to put a question. How many of the students know the difference between AR and VR, augmented reality and virtual reality? Can I look at the gallery? Any takers for this question? Would anybody like to go have a go at this question? AR and VR, please. All the
Students,
cameras are off. Anybody?
Students, you may use the chat box for replying also.
Yeah, please. Right, well, sir. Either can chat if you feel any audio issue. Okay, I'll continue. And VR is virtual reality is no reality as such. You are just, it is used for example, in our company, maybe we'll be doing something in the academic sector with virtual reality where we cannot have the real thing inside. Like, for example, in medical students, in the case of medical students, in some cases, like when human body is called a cadaver, CADAVER. A cadaver is not available for what should I say, Sham? Or I should say for study in the first year. It happens now because a cadaver can cause epidemic. So we have a virtual cadaver and a virtual reality. You wear the virtual reality specs, and there you are. You're reaching wherever you want virtually. But there is nothing, no reality at all. But in kind of augmented reality, we have something like what I don't find anything. Yeah, like this instrument here. We have it, and we weave stories around it to make you understand. Our academics division is doing a lot of research on that. Our R&D wing of academics is doing a lot of research on that to make students, engineering students like you, to learn the reality by having some real stuff there and building things, weaving things on that is called augmented reality. Right as the word goes, augmentation, as augmenting things, improving. But virtual is something which is totally weaved around, which is a replication of the reality. And augmented reality is reality plus something more.
Excuse me, sir.
And now,
Yes, just wanted to add, we actually have this the same project, virtual cadaver using virtual reality by one of our
yeah,
final year student. Actually, he got passed out
great,
last
great,
year.
great,
Yeah,
great, great. So he's doing that now. It is very much
yeah,
useful. I
yeah, yeah.
think he will end up in a good position. Okay. I mean, we can spread the word around. He gets employed very quickly.
Sir, actually,
Okay.
he got employed. He is now working with
Yeah,
UST Global and
yeah, yeah.
again
Great,
continuing
great,
with the
great,
project.
great, great. It is. Convey our appreciation, congratulations to him.
Sure, sir.
That and so he mentioned one boy, one engineering student, who drove the technology rather than getting driven by it.
Yes,
So that's why all of our students who are attending this 45, 50 of them should be driven, should technology or rather change should not drive them. They should drive the change as a typical example given by Arun. Claps for that. Okay. Very good it was. Okay. Now, that is what is augmented reality, and I'm sorry I'm drifting. So 4.0 is formed in Germany. It's a high-tech strategy of the German government. And who are they? Who are behind it? These are the people behind it. Uh, Various chairs and co-chairs, different people. Just showing you a picture of who are there. Then the ladder, the stepping ladder of a connected factory, smart components, smart machines, then digital, connected, and then industrial enterprise. Okay. Now in 4.0, what do you have? Robotics, advanced robotics, and additive manufacturing. Students of I mean, this civil and mechanical will be interested. Now, students, Arun, what happens when we go and a car, our car now
yes, sir.
gets broke down somewhere. Old car, maybe 7 years old car, gets broken down and no spare available. Okay.
Yes, sir.
Okay, one spare is not available. So we have to the service center has to contact the factory and get it. Till that time, your car will be taking a rest. It will be resting in peace. Now, in the new industry 5.0 workshops, what you can do is you can drive your car to the garage. They will do a 3D printing of it, the spare which is required to be replaced. By the time you have your supper, or not supper, I mean lunch and back, that it will be printed and fitted actually. That is additive manufacturing. Okay. Augmented reality explained already. Simulation, that is process simulation. I'll give you a beautiful example of a digital twin, which Sham and I actually had seen that. We'll show it to them. And then simulation, then the vertical integration, all those things, industrial internet. These are the ingredients of 4.0, which take you to the next level. So, students, what is happening is you have to live with the change. Skill set required for 4.0, which is currently going on, is IIoT, AI, smart technologies, AR, advanced robotics, etc. Irrespective of your field, even if as a mechanical engineer, you need to know this. As a civil engineer, maybe also you also need to know it. Okay, especially in the smart cities, because a gamut of opportunities are opening up in the civil industry, in the smart cities for civilians, civil engineers, I mean, not civilians. So 5.0 skills are different. It is a 4.0 subset of 5.0 with what? I'll just tell you. So mundane jobs are getting wiped out and more skilled engineers required. So what is happening, Aaron? There'll be bombardment of opportunities for engineers for in every sector, because the the old experience of working in the conventional factories are dying out. So we need good smart engineers from your college, Arun,
Yes, sir.
to cope up with the demand. Now it happens, as everybody is saying, where people are entering with bank jobs, clerical jobs after doing what engineering, and ending up in the secretariat as secretary assistants and all, and that is actually foolishness when such a big opening is waiting, is lurking behind. Only thing you have to identify it. Then 4.0 is for today, and 5.0 is for tomorrow. Okay. Now we are at the cusp of this fifth industrial revolution. So what do we do is personalizable autonomous manufacturing. In Industry 5.0, I don't know what you know now. When you go to a hospital or somewhere, you you have a coffee blending machine or a tea blending machine. You have to set the settings now to
Yes,
have the tea of your taste. In Industry 5.0, you do it once, and next time you go there, the machine will automatically give you the tea of your taste. That is what 5.0 is for you. Elementary example.
okay.
Fourth, we have cyber physical systems coexisting, which I told you. They are basically robotics will change to cobotics in the 5.0. Now we are entering 5.0. We have a series of pictures here which shows how a pick and place robot is doing its work. Here we are in the 5.0 environment, and lack of time, see, I can talk hours on this, but I just quicken it. It's saying 1 2 3 4 5 6 7 8 is only for your sequence of events. So once the job is lying here, it is placed here, and this is the scanning plate. And what is happening, it is scanning the hand. The robotic arm is scanning the hand, and what is happening is there is a camera here is reading the palm, like palmistry, you know and the from the mind of the human being, the design work of what is to be done is taken and is done. So it is different from the programmed robots who do things repeatedly. Here we have in 5.0 cobots which are trained to do work as per requirement. You don't have to change the program every time. So how will it affect the manufacturing system 5.0? There will be an HMI. HMI is the key word in 5.0. HMI. So human machine interaction is cobots will be different as the organization interaction will contain human-like functionalities will come. These things will take away the dull and dirty mundane jobs and create more jobs for engineers. Intelligent robots and systems will have the penetrating will be penetrating CM, supply chain management. Okay, and then robotics will become cheaper as we go ahead. All this will happen, students, as you are moving from one semester to the other. Lot of jobs are going to be created. Robotics, maintenance, training, scheduling, repurposing. What repurposing is, we'll discuss later. I don't have much time. Invention of a new breed of manufacturing robots will come up. And now we come to the applications. We are going as per schedule, okay? Now, what are the IoT or IIoT applications? IoT and IoT I am using interchangeably because here mostly we are dealing with industrial IoT. IoT is the generic name. IIoT is industrial application. And home IoT, what does it have? Lighting bulbs remotely, pet feeding, irrigation controller is there. There are certain microcontrollers meant for irrigation, for humidity sensing and all that. For example, we have on the terrace, I don't know, you have on your terrace
Yes,
drip
sir.
irrigation because you don't feel like climbing up the stairs. You have a 3 or 4 storied house and you don't have a lift, but you still want fruits and vegetables to be homegrown. You want harvesting from the terrace, but you are so lazy, you don't want to climb up for watering the plants. So we have this diaphragm pump with drippers connected wired through to all the plants, and then you have an IoT stack, and then you have your program running on that. So you fix a schedule, you program a schedule from your application layer, say drip it at regular intervals on the day for a few minutes. Now, if we are using this irrigation controller, then if there is rain, it won't, the motor will not be switched on. So you'll be saving water also.
Okay.
And if the dryness is more water will be sprayed, will be dripped. So that is how it is used in irrigation, IoT. Transport and mobility, please wait a little bit, we are going there. The health, also we are going there. Building infrastructure, we just explain it. It is the old days of building management is giving way to IoT enabled intelligent building management systems, where even like power is supplied through the data itself, data is supplied through the power lines itself, so that a house, what should I say, like a consortium of flats in a building can have its own billing with permission from the electricity board, and the billing can be as per usage only, and you can prepay also. All these things are possible under building management, and also energy saving. Unused lights will be switched off automatically. Fire alarm, smoke will be detected automatically, so on and so forth. Then we have the smart cities that I'll be discussing right now. Okay, it's time for a small poll. Ananta is there now. He can push a poll actually.
I can launch it.
Yeah, please, Sham.
First
So
poll,
nice of
yes.
you. 1, 2, 3 only. The first three polls. One at a time. One at a time. Yes.
The first
Students,
poll,
please feel free.
yeah, the first poll is already launched.
Yeah.
There are 3 questions. You can scroll down on the right.
Yeah. Please.
Good. We are getting
Right.
responses.
Yeah. We're getting good responses. Students, this is meant for you only. Our time, our TNC is for you only. Be participative and interact as and when necessary. Time is less. If you can send chat questions also, so that there is no interruption as such. I'm forced to say that because we are at the halfway mark, I think. Yeah. Yes, half time now. Okay.
1 minute is up. I'll give 1 more minute.
Yeah. Beautiful. 17 out of 52 have answered. Students, hurry up. Arun, I think you can ask them to.
Yeah.
Half a minute more.
Yeah, good.
For 15 seconds.
Yeah.
10.
Please hurry up. Your time will get
5.
out now.
I'm giving 5 extra seconds.
Yeah. Don't miss the opportunity. When an opportunity is approaching you, it looks small. When you lose
Okay,
it,
and I'm
the
ending
bigness
poll.
will be. Yeah. Okay. Please.
So shall I
Now
share the
let us
result?
share this. Please do that. Okay. So ESL is electronic shelf labeling, rightly answered. So people are knowing about the technology. Then IoT is possible to go to a shop. Yeah. It's quite possible and it's very much required in these days. IoT stands for this, beautifully answered. And I think majority, Sham, have answered correctly. And let us go to the next poll fast.
Okay. So now stop share results.
Yeah.
Let me go to the next poll. How do I go?
Beautiful.
Polling number 2.
And Dr. Ajit, the question for the first 3 polls are only in the first 2 polls. That is poll number 1 and 2 only.
Okay, Ananda, let us. It's okay. So second poll. Now, there were only 2 polls you made.
Yeah.
Right?
So go to
Okay.
Ananta, polling number 2. Shall I launch?
Yes, please.
Let us go fast.
Yeah, again 3 questions.
Yeah.
Just 2 minutes sharp. This is quite easy.
Yeah, all questions are easy actually. Another, you're back good. You're there.
1 minute is over.
Students, as Dr. Ajit also mentioning, please use this time also to type in any questions that you are having on the chat box.
Yeah.
We'll be more than happy to take up those questions.
Please type in your queries as it happens. Keep your mind clear.
Yeah, I think I'll give another 10 seconds.
Yeah, that's good enough.
So this is an easier poll.
Yeah. I made
So
it easy. So
I'm ending the poll. I'm ending the poll.
Please.
And I'm sharing the results.
Yeah. So Indian Regional Navigation Satellite System is right. And true. Brutal will drain your battery life. And beautiful, I answered Wi-Fi also. Now there are two frequencies of Wi-Fi. One is 2.4 and now one more has started a few years back, 5 gigahertz. 5 gigahertz and 2.4 is right. That's all. I think another will keep moving, huh?
Yep.
Yes.
Yeah, I think we can stop the results. I'll just close it. Okay. Okay, now we are into the applications, and first is a smart city. A smart city meant for smart citizens, where idiomatic mundane jobs are removed, and physical movements are reduced, and efficiency is increased, and you know, and you know, uh, speed of operation, like paying a bill, electricity bill. You don't have to go there and do it. You can do it through a smart meter, and the shocks of having a bill suddenly landing on your face with a high amount, causing cardiac problems, is removed. All part of the smart city. Okay. So what all we have? Smart energy. Smart energy means in a smart city, your lights will keep working even if there is a power failure in one grid, because another grid will take over. There's a smart hybrid system where conventional forms of energy sources will blend with non-conventional like solar, wind, etc. So that a smart hybrid is formed and energy is taken from wherever it is available to give you uninterrupted supply. Okay, right. And then smart governance means movement of files, like in the Trivandrum Secretariat. Nowadays, if you go a few years back, you cannot find the face of the clerk because of the heavy stack of files in front of him. Now those stack of files are in the cloud, and he will look at the monitor and tell you the status of your file. Okay, in a smart environment means a green and smart environment. That is, I'll show you an example in a few seconds from now. Then smart transportation will explain now. IT and communication for a larger wide area networks, then WiMAX, Wi-Fi, everything will be available for you in a smart city. And most of you can land up in smart city projects because it will be a boom by the time you pass out. Okay, and you have to calculate iron and the management. Then now we have an autonomous college where you're studying. It's a great thing to have. One of the first three engineering colleges given the autonomy status from the AICTE and the university, the technical university. Okay. Now this is that smart and waste management. This truck is a very smart truck. It has a tracking system, and these are smart pins. So they talk to the cloud when they are full, and they will inform the cloud will inform the nearest truck to collect it because it is full. That is possible. That is there in everywhere, in not only in the city waste but also in biomedical waste. factory waste also, all classified and collected like this. Okay. Now the smart city projects. These are the various smart city applications: data warehousing and traffic information. Like you have put your money in the bank, likewise this is a data centers are available where you put the traffic data, the traffic rules and regulations. Your vehicle data will all be in the cloud, in the data center. Then here we see the various applications of the smart city where civil, mechanical, electronics, every engineer works here. One is, I'll start with the bottom portion, incident response system. Like when you guys are standing in the bus stop and find a case of chain snatching, immediately you have a call box there, or you have a citizen app is there in your mobile. You push one button and you connect it to the incident response manager or the executive, and immediately your lat long and map is sent there, and the police is rushed there. And as the police comes in, the adaptive signal controlling will take over, and it will be green lights everywhere to that point where you are standing, where the incident happened. Okay, the lights will be turned green before a cluster of vehicles is formed. Same is the case with ambulance. If it is a medical problem also, more importantly, it will be done that way. Okay, so that is an advantage of incident response system. And then the dynamic parking guidance system means here in the dynamic bus platform system is where the buses, as you find in the KSRTC bus stand here in Trivandrum, what happens is that buses are fighting for the 10 or 15 platforms available. It is survival of the fittest, and those feeble or rather weak drivers have to put their bus somewhere else. Here it is not that. 1 or 2 kilometers through LoRa and the BLE networks, as you approach the radius of 1 or 1.5 kilometers, your platform number is visible on your dashboard and will be guided to that platform. Similarly, if an ecosystem is existing now, will be existing in a smart city where you drive your car or bike to a parking area in the bus stand, and you are not expected to drive to your work if it is more than 50 kilometers away. You can use the public transport so that the congestion is less. And there are so many such applications of all are IoT based. Okay. Now, public transport information systems and passenger information systems in such a case that if you go to one junction here, say Keshwaswaram Junction, which is an important junction near to your college. So there, what happens is that you have sometimes what will happen is you are come to that junction, come to the bus stop of Keshavadasapuram to board your bus. You will have a passenger information system display which will guide you, will tell you the ETA, that is expected time of arrival of a bus with a route number, say route B. You boys would have thought that the bus has gone and would have taken a direct bus to say Kovalam. Might be expected at by the timetable is as per at 5:30. You reached at 5:35 and thought that the bus has gone, but actually it has not gone. If you have a PIS, you will be told that this is coming only in the next 7 minutes. I hope it is clear to you. The vehicle tracking and tracking systems will be explained as a case study. Dynamic route marking is that you will be guided from Keshavaswaram to Eastford. You will be guided with the guided by IOT stack to take the least dense route without blockage. Okay. Now a small video I'll show you on a quick run over of a smart city project which we are associated in Surat. I'll try to bring one of the project managers there from Calcutta onto the stage tomorrow. Let me just try.
Surat Municipal Corporation.
Is the audibility there?
Yes, sir. It is all.
Okay.
Snack Center. Surat, one of the fastest growing city, has 6 million population. Authorities managing large city area and population need smarter solutions. SMAC Center is the smart command and control center of Surat Municipal Corporation, made operational on the first anniversary of Smart City Mission. SMAC Center uses digital technologies to enable with centralized monitoring monitoring and decision-making capabilities with real-time response management and emergency response management. Feed from CCTV across city helps to proactively monitor and manage municipal services. Monitoring of intelligent transit management system and automatic fare collection system has helped to make city and BRT bus service effective and efficient. Cases of bunching, route deviation, stoppage violation.
You just saw a bus rapid transport system. It is applicable in cities like Surat, second or third tier cities where metros like in Cochin, Mumbai, etc. are not available. It is a single track road with buses stopping only at designated platforms and guided through IOT stack.
Surat Municipal Corporation managing large city area and Surat Municipal Corporation on the first anniversary of Smart City Mission. Smart Center uses digital technologies to enable with centralized monitoring and decision-making capabilities with real-time response management and emergency response management. Feed from CCTV across city helps to proactively monitor and manage municipal services. Monitoring of intelligent transit management system and automatic fare collection system has helped to make city and BRT bus service effective and efficient. Cases of bunching, route deviation, stoppage violation, overspeeding have been substantially reduced. Monitoring and management of 600 solid waste vehicles to ensure adherence to 1,400 trips covering 10,000 POIs. With effective monitoring, the count of missed POIs has been brought down from 500 to less than 10 per day. Monitoring of vector-borne disease control activity has helped reduce positive malaria cases by 49% and annual parasite incidents API by 43%. Complaint analysis team to identify and understand civic issues based on the data and insights from comprehensive complaint management system. For current year, 99.61% compliance ensured for over 75,000 complaints. SMEC Center further utilizes the feeds coming from other smart city solutions like smart street lighting, sensor-based smart underground dustbins, environment sensors, feedback devices, intelligent parking system, smart biometric and GPS-based attendance system, and many more. All these ICT-based solutions integrated with the SMEC Center is helping SMC to improve service delivery. Over 82,000.
So what was shown just now was the different layers of the IoT stack and the control room, which is the application layer, controlling the city from one point. All information will be acquired there regarding the city, and corrective and preventive actions can be taken from the control room. As I told you, application layer, one part is controlling, monitoring, and other part is monitoring the staff also there through various third-party applications running on our application layer. That is clear. Okay, now along with IoT comes the trouble of cybersecurity. You don't want anybody to hack into your system and spoil all your good work. Even in a your IoT AC, just imagine somebody else hacking the thing and switching on and switching off at his liberty. It happened in the early days when this was developed by Onida. One of those engineers was talking to me. So cybersecurity is a key element, especially in public platforms. The IoT security is the technology area concerned with safeguarding the connected devices, networks in the IoT. There are a lot of incidents of IoT being hacked and compromised. So safety of networks, IoT devices connected to them is of prime importance. So as the IoT expands or exponentially expands, so is the risk of hacking. So by 2020, there are a lot of cases have been reported. I show a few of them where worldwide it has been hacked and a lot of problems were created. The first one was hit in 2016. Then the botnet, that is a kind of robot, it compromised the security on a number of IoT devices including the IP cameras and routers, I mean, and they converted into botnets. This was done this was done to show the strength only. It was a planned hacking or a semi-ethical hacking. And both for academic interest, it's a software application for doing certain tasks autonomously. And they are through a program without a human intervention. And this is actually a malware. It was only an advertisement, and the problem was removed. Then there is another malware called Mirai that infects smart devices that run on the ARM processors. They will be converting into zombies. So just examples, just to know why cybersecurity is so important. Then in Ukraine, what happened? There was a power outage because of a malware called black energy malware entering the cloud. And the technical support phone lines were jammed by this malware. Then in Atlanta Smart City, what the hackers did was it locked out the employees out of the network. A network, they were shown now that smart city, at this point of time, their mind that a smart city Surat control room should come. Just imagine the power being seized from them by the hackers, and they can do anything, with the city.
Yes, sir.
They encrypt, right now, Aaron?
Yes, sir. Yes, sir.
They were forced to shut down to prevent the virus from spreading further. Lot of data was destroyed by that. So we learned from these examples. Then in Singapore, even the Prime Minister's health data was affected. Sing Health is one of the largest healthcare centers in the city of Singapore, or the country of Singapore, I should say. And it took away the profiles of so many patients, 1.5 million, with their prescriptions, etc. Actually, we took this was in our mind when you're developing a project nowadays. Okay. Now, how IoT's challenges are mitigated. So privacy is actually a serious concern everywhere. The hackers are capable of crafting attacks. Hackers are the best software engineers in the world. According to Cisco, what is happening is there are more connected things than people, as we saw also in the graph. As I told you, 50 billion people are getting connected by 2020. What are the security problems? Insecure web interface. We have taken that into account. We have taken that into account when we were developing our project. We are making it 100% secure by various means. MTTP protocol has been used for that. Proper authentication is not there, then you had it. Network services have to be secure. Encryption at the transport layer should be there. Concerns of privacy should be addressed, should not be ignored. Cloud interface should be secure. So we have to take the proper platforms like AWS, GCP, Azure, etc. from different branded providers. Then security should be properly configured. And physical security also should be there. At the end of the day, it's not that it's kept open and somebody can cut away and copy it. As in Bombay and all, as Sham was saying, now if you have a motherboard of a branded PC, it can easily be copied. So if the hardware is not kept in secure condition, somebody can copy the hardware and maybe develop a similar code. Okay. Then this is how it gets compromised in different layers. I think discussing further at this point of time may be intruding our time management. So I'm just leaving it with the note that various layers of IoT, application layer has this many security risks, cloud has this many like that. It goes on like that. Communication layer. Just understand that we have to address the different security issues of the different stacks of the IoT, like cloud. Then yes, somebody has told something. I don't. Somebody is still muted, I think. Then gateways, then various gateways are there, which also are having threats like that. Okay, the data types, threats like that. Just wanted to show you different types. Then how do we take action to prevent compromising the security. Please authenticate the edge devices like sensors. You have proper device and MAC ID. Don't duplicate the IDs. Disable the physical interface in edge devices to prevent software modifications. Have proper level layers of authentication in the remote access mode with OTP, etc. Always change the default passwords. Never keep the default passwords from the factory. Cisco keeps its modems under a certain password, which they themselves say, please change it on installation. So we are now discussing how we attack the security issues layer by layer. So device layer continuing, we have harden all the edge devices in line with the minimum baseline security guidance. Encrypt the communication channels. Always connect to the authorized wireless network only. Update the firmware through FOTA and OTA. That is to see that all security threats are mitigated. And what about the gateway layer? What do we do with the gateway layer? Divide it into multiple zones. Segmentation, one way. That means that identify the critical zones as the trusted zone, management zone, production zone, and all those. Divide it into different zones and have different plans for different zones. Use proper firewalls like Cyberdrome, etc. Secure the data center network through external firewall also. Web application firewall should be there, intrusion prevention and detection systems and other security products. Then use the guidelines published by TRAI and Department of Telecom. Implement authentication with secure protocols like FTP, SSH. SSH presently we are using in our project. We could also use HTTPS and TLS and even MTTP as long as we are working with the various devices. Use encrypted channels. And, don't leave anything open, like any unused network should be immediately closed. Then what about the data layer and the data analytics layer? We are taking both in one go. User authentication firm on databases. Give access only to authorized persons. Deploy the database server into a segmented zone, spaced out from the app and web servers. Perform hardening of the servers as a minimum baseline. Then continuing, channel encryption. Some data is repetitive for different layers. Encryption keys to be stored separately. Conduct backups or hold or take backups regularly. Follow certain guidelines in SDLC process for custom developed applications. Provide privileged access to servers to authorized users only. Perform hardening and repeat. Always use OTP or other authentication mechanisms in building the APIs and APKs. Then again, in the application layer, create a role-based access control. Use HTTPS or the mentioned protocols like SSH. Validate user-provided inputs. Implement error handling mechanisms and end-user inputs. Don't put anything as default. Generic some things are there. As I told you, TRAI and other government regulations you have to follow in a generic way. Use only authorized access. Design and implement as an SOC with advanced analytical capability to detect, respond, and recover from security incidents on a 24/7 basis. Ensure integration of all systems. Okay, perform security testing. This I wanted to say your level of your students are not that much to digest all this. I just want to run you through this. So as this will be more interesting to you, that is change your router's default settings you do at home. Then use strong passwords. Update your device routinely. Two-factor authorization you can use. don't use universal plug and play feature unless it is required. That can land you into trouble. Now, these are the Government of India's efforts on cybersecurity. For Housing and Urban Affairs has something on cyber city, smart city. Then this NCHS, NCHPC, Information Infrastructure Protection Center of the government. Then security policy of the cyber security policy 2013, IT Act, modified in 2000, are all the government initiatives. Then Aadhaar, draft of the personal data protection bill is in place. Draft of the digital information security in healthcare, that is called Disha, also is in place. And now we come to applications in the shopping area. Like as you answered rightly, you can now in the pandemic area, it is possible, maybe in Industry 5.0, it is possible that you walk in without meeting any person and without touching anything. You walk in. What happens when you walk in? When walking, the doors will open automatically if you are authenticated. If you have the proper authentication, it will be opened, and you'll go around the different shelves. The shelves will talk to you through electronic shelf labeling systems, so you can identify your thing. You take the components and put it in your tray or shopping cart, and immediately the tray will inform the storekeeper that I am finished. Please replenish me, put more things into my track. And at the time of payment, it will be through automatic payment. That is cardless payment. No, boys, that nowadays even we have Wi-Fi, RFID, this thing, debit card. In the pandemic days, that becomes useful. You don't have to touch any machine. Your debit card need not be touched by the shopkeeper. You just go near to him with your debit card in your pocket. Immediately the POS will sense your card, and you just have to key in the password, or rather the passkey, or whatever you call it, PIN. Now I'm just showing you a brief video on electronic shelf labeling.
I've been sitting in the darkness, but the sunlight's creeping in. Now the ice is slowly melting in my soul and in my skin.
I'm explaining just how this electronic shelf labeling is IoT enabled. This is a part of the smart shopping experience. There are various, these are all on e-paper, wherein the values of the prices get changed through the IoT stack. That means you don't have to go to shops and other shopping establishments. You may take one item and find a label on the shelf that 50% offer. When you go to the shopkeeper, when you go to the counter, oh, sorry sir, this offer was valid only till yesterday. I forgot to remove the sheet, remove the poster. That won't happen here. For example, this price you see here is current. It may change in the afternoon if there's an offer. Okay, that's what I mean by that. So going further, we have different types of shelves. That's an example of this one. And now in dairy farm, this actually is a real life experience I experienced in Sweden, an island in Sweden. There, through IoT stack, they are monitoring their cows. They take a steamer, go to the island and put their cows and in sheep there for grazing all the day, and they will have vertical sensors installed them, and RFID and other tags, and LoRa sensors, and through a access point, they can see from the farmers will have some other jobs. Maybe they'll be vending out materials in a shop, or maybe a shopkeeper during the day, and the sheep details, whenever they get time, they have a look at it in their control panel, the application layer. This vertical tilt sensors are called. If The tilt sensor gives a wrong signal gives the bad signal. That means it is horizontal position for more than the stipulated cattle time. I don't know about those details, but I mean, if it is having some problem, it will be lying on the floor more than standing on its four legs. Then they immediately take action. Then any other intruders are there that also can be sensed. So what I've seen, a plethora of sensors in action, and this farmer doesn't have to waste his time grazing his cattle, looking at his cattle. He can do another job and earn money, and also take milk. And these cows will be well fed also by this method, by IOT stack method. And happy cows will of course breed more milk, and that again makes the farmer happy. So he earns from the uh, shop, and he earns from the herd also. That's what it is. Now a very important industrial application, solar energy. Solar energy by from using the IoT stack. This is just for introduction of how the solar panel works. From the solar panel, there is called PV. The photovoltaic cell generates transducts the solar energy into millivolts. It has a specific per PV value. That is, this is a panel. Then what it does is in DC. It is amplified and inverted for AC, and given to a circuit breaker for controlling the flow to the grid, to the utility grid. It goes here to the utility grid. Okay. Now, sorry. And we have the control board and communicator. It's a conventional thing. Now, an IoT comes into play of a solar panel, solar system. For example, the big businessmen have a solar panel, have a solar farm in Tamil Nadu, in a hot area, some in Rajasthan maybe, another hot area, and somewhere in Ethiopia, a third hot area. Uh, Now, without IoT, he may have to visit them regularly to see how it works, and he has to send somebody always to attend even minute complaints or problems. With the IoT stack, each solar panel becomes a node. A few nodes in Tamil Nadu, a few other nodes in Rajasthan, and some in Ethiopia, and some in Sahara Desert maybe. So what happens? You can put solar plants in places where humans find it difficult to reach and still control them, as you see here. The PV cells, analyzes and controls have become the necessary factor for remote solar farms and for intelligent fault detection and power optimization. Okay. The management of a PV array requires an embedded system circuit so as to create an SMD. SMD is a smart monitoring device attached which each panel, and this is where he is attaching it. These engineers are doing that, or the technicians are doing that. It is used for sending the data and also for fault detection, detecting the fault. So the SMDs include sensors for monitoring voltage, current, temperature, irradiance, etc. at each individual panel. And the latest SMDs include a radio and relays which allow the modifying of the solar energy connection topologies. That is, azimuth of the solar or the solar traction can be corrected using this SMD. And with this SMD, each solar panel becomes an node in the IoT topology. That's what I want to say. Arun, should we take a small break and welcome questions at this point of time? Arun, what do you say?
I think we can take it in the end.
At the end, okay.
Yeah.
Ajit, it is 6:45.
Yeah, good.
So
Arun. Please,
Ajit,
if you want to
15
take
minutes.
questions at any point for a discussion, I am ready for it.
Yeah, students, you can post your questions in the chat. We can take it towards the end of the session.
Sure. Ajit, you got 15 minutes to 7 p.m. No?
Yeah, that's right. Don't make me tense, huh? Okay, now this is the SMD, the solar panel, the module, the electronic system I have shown you there. And this is the panel. The panel here, this is the panel, and this is the SMD module. Okay. So here I am showing you both just for completion point of view. So what does the solar energy IoT system, what all it can do? What are the features? It can do a dynamic analytics, enable solar farm control. The farms can be one in X, one in Y, one in Z. Detect and remedy faults, optimize the power under different shading conditions. That is a very important thing. And then reduce inverter transients also. Inverter transients, sudden the change in load can be optimized using IoT stack. And from the comfort of a palm top or a laptop or a mobile, the solar farm owner or his authorized subsidiary can see what is happening and fix errors by sending a technician in advance, so that a stitch in time can save 9 or hundreds of stitches. A network you see it may be running perfectly, but your IoT stack may report an error, and you can know from that whether it's a network related error or a hardware related. In much time is wasted without an IoT stack. Maybe a physical visit may be required, thinking that it is a hardware error. But when you go there, only you will understand that it is a network related error which could have been solved without a physical visit. So it provides intelligence to you to identify issues in real time as error occurs, so the source can be located and resolved quickly. Okay, now using IoT, your solar system will be less susceptible to outrages and productivity issues and potentially costly security breaches. By installing an all-in-one edge-to-cloud solution, edge computing is a part of that. We don't leave everything to cloud. So you put a part in the system itself, an embedded system, so that a fault tolerance is established. That's what is meant by edge computing. And then in addition to providing companies real-time alerts, leveraging the IoT can improve the power quality and performance by collecting historic data. And here AI also comes in, students. By doing a heuristic analysis, you can do something in forward also. Just understand that at this point of time. I don't think I'm talking in a very higher level than what you can digest. I hope so. Then the challenges are that the network related challenges, there are so many. Even now today, I don't know whether next minute I'll be disconnected or not. The networks are so bad. And even if the system is fully integrated, and we need to have the proper software and equipment should be upgraded every time to meet with the challenges for delivering the sufficient energy. Okay. Now further challenges. The further challenges are due to inclement weather, as it happens nowadays due to monsoons. There is a fluctuation. So the power grid has to adapt to these changes to ensure that you are maximizing the grid usage and load at all times. This is not necessarily under the control of the IoT. That is a challenge. So the seamless interaction is what is the order of the day. Okay. Now the very important thing with the advent of Make in India, it is good to know all these things. IoT, how it plays a key role in production and manufacturing. The idea of see, you must have gone for IV, no? Industrial visits. I don't know. Are there industrial visits over IV?
Sir, actually, this year we will not be having. Actually, this was the apt time for the third year IV. So it got cancelled because of this situation.
I think we can arrange some that AR, VR, no? Augmented reality, virtual reality tools. We can take them.
Yes, sir.
Just to as a compensation. Okay, later on. Okay, now so they may have these youngsters now. This S2 first years may get a chance later on, no? After 2 years.
Yeah, definitely, sir.
I don't know. When they go there, they may be seeing a connected factory in the next 2 years. The concepts are changing. No? There is a disruption. Okay. So what IoT does in the thank you, Arun. So what IoT does here is digitally transforming the manufacturing sector and production sector by employing a network of sensors to collect critical information, data, and using the cloud software, that is application layer, to turn this data into intelligence, valuable insights about the efficiency of the manufacturing system. So both the shop floor and the top floor means the senior management, can get a view of the production. Gone are the days, as you see here, when the MD or this, like when Sham and me were working the Bokaro steel plant, we could see the GMs and DGMs standing on top of our neck just to give pressure, or because if they don't stand, they feel that they are not getting the right to the direct information. They may be left out, they feel that. For example, I remember one inverter card failed in the lab from the ED to GM to AGM, all were in the lab hovering around me working on that. So that gives displeasure, a discomfort. But they are doing it because they don't have access. Those days, IoT was not in place. If IoT was in place, they could understand what was happening by sitting in the comfort of their room and making life of others easier. So that can be avoided. That the top layer or the top floor management also gets access to the problems. I don't want to go into the intricacies and nitty-gritties of this because we are having more of S2 students. Okay. Now, what are the impact dimensions? First is visibility in the shop floor and field from the top floor that I showed you or explained to you just now. Second dimension is the visibility into the manufacturing supply chain. That is the MD or the GM supplies. Like in Bokaro Steel Plant, or my senior Sham's friend is the head of supplies there in Bokaro Steel Plant. So there, what he can do is nowadays through connected factory and through IoT, he can sit at home and see the supply chain right there unfolding in front of your tab. So he need not worry about the MD calling and telling, or the ED procurement or the ED projects or whatever calling and saying, this component has not allowed, this machine, this CRM mill one component has not arrived. He knows where it is and he can immediately answer. He doesn't have to make a few phone calls and say that the other end is busy. Okay, that's how it is. The fourth dimension is asset tracking. That is, many computers, many things are there. Through the procurement head can see where things are, to at least know where they are and track them. And we have another dimension, that is visibility in remote and outsourced operations. That is, nowadays is the order of the day. In our project also we are doing that. Some things are outsourced to somebody else, some other company, factory. We can get into their server and see what is happening and getting it using their sensors. These are the three things. So I'll run through the dimension one. We have an automated workforce management system. So it simply means a set of sensors connected together, and the whole process being reported through the cloud to the cloud. It allows manufacturers to gain a higher level of vertical visibility into two groups, that is supporting and manufacturing operations and facilitating industrial asset management. There are two things in production. Now, one is the operation and the other is materials management. They will get a bird's eye view of what is happening. And at the lower level, shop floor level, they know the reorder level, exactly when some things go out of stock, they know. There's no delay which happened in our times due to lack of a component. Like in our central instrumentation lab where I was working as an electronics and instrumentation engineer, for repairing a field transmitter which had no spare on the site, we may had to wait for weeks to get a spare from Bangalore or Ahmedabad or somewhere. Okay, so those times are gone. So manufacturing processes, I'm not going deep into it. Here what is happening is through SCADA and through data control systems and acquisition systems, if we get an idea of which parts are going wrong and which parts are available. It can pull the relevant data about machine operating parameters, example runtime, actual operating speed, product output, etc. from sensors through SCADA and DCS. Then product quality control, again based on sensors, monitoring the quality of the product, the products, done by monitoring the condition and calibration of production machines on which a product is manufactured, so that with the healthiness is maintained, so that we get proper products. The work in progress can be inspected at any time without a physical visit by the help of the sensors. The quality control based on work in progress inspection is applicable only for the discrete manufacturing, and costly, time and labor intensive it is otherwise. Okay. Now, product quality control based on condition monitoring. This condition monitoring is a new platform where IoT stack is used. Like, for example, Arun, human beings now nowadays are more prone to executive health checkups where they do a regular checkup and get
Yes, sir.
what I say, your heartbeat, your pulse rate, your blood sugar level, everything checked before a catastrophe happens. Likewise, sensors tell us about the condition of the various parameters of a machine, production machine, so that a breakdown can be avoided. That's what it means. The safety, also safety aspects. Wearable sensors are there. For example, mining, in the mining companies like Coal India, etc. You have seen now many deaths in the last decade and all. There, we always can monitor them through RFID tags and wearable sensors against contextual data. Means if their behavior patterns changes, for example, there is no movement for some time, it means that he is trapped under the soil in the cave. So such information, without they knowing, we can track and take remedial action. Like sudden vertical movements, then unusual heart rates can be monitored inside a mine. Boys and girls, I don't know, it is tremendous, the scope of IoT. It all means jobs for you in the future, next 4 years, 3 to 4 years. Continuing with the monitoring of safety, uh, if a person suffers from overheating, like standing near a blast furnace of 1500 to 600 degrees centigrade, if he, before he gets a stroke or something, people will come to know through the control, through the IoT stack. Then the second dimension is the visibility across the manufacturing supply chain. As you know, a supply chain means different things, starting from the raw material to the finished product. So everywhere there are sensors which keep you informed of the progress of the supply chain. This is for the procurement. That visibility will be there across all the chains, like the manufacturer is here, the driver, where the truck is can be seen by the procurement manager instead of calling him. That will be explained in various case studies. Okay. Then visibility in the remote and outsourced operations, like many companies, a portion of the process, some jobs will be outsourced. Even TNC, our company also does that, and many companies do. The reasons are, if you do it yourself, the cost will be more, and they are more equipped to handle that. And also because of the global supply chain management, because some geographical, to make use of some certain geographical advantages, like in steel plant maybe, or rather like in say manufacturing itself, like it is a company called Noratel, a Swedish company in Trivandrum Technopark. They are selling as made in Sweden, but actually many things are made in India under outsourced operations. Why they are doing it in India? Because of the geographical advantage of cheaper labor. I think you got the point. So third dimension is visibility in remote and outsourced operations continued. The IoT-driven utilization monitoring solutions help manufacturers to keep an eye on the efficiency of the manufacturing operations. So the managers can now see the efficiency by getting real-time equipment efficiency metrics data. And when it is in a different city, it builds or buys a manufacturing facility in a different city, state or country, it still has to maintain its manufacturing or production standards. That also can be controlled through IoT stack. For example, Sony Corporation, the Bravia TV may be made in China, but it will be as per the standards set in Japan. So in a connected factory, the sensors and the IoT stack will push the data to the control engineer, the production planning and control engineer sitting in Japan, to see whether the quality metrics is met or not. There also the IoT will come into play. Then asset tracking. It's very simple. As I told you, this crane is moving around. Where that crane is, through the RFID tag, which is known and sent to the database. For example, in our steel plant, where there used to be an operation garage called OG. OG. That operation garage is responsible for sending vehicles to the required departments. In those olden days, they had to rely on telephone. Not even mobile phones were there. They had to rely on calling the nearest plant or sending somebody on a scooter or something to find out where one vehicle is, one truck is, or whatever. So here it is possible through the IoT stack. The predictive maintenance is possible through IoT stack instead of plant maintenance. I had mentioned it as an advantage. Here we put sensors in the, for example, if it is a turbo generator, various points to know the current, the armature current, to know the vibrations, etc. If it is beyond a certain limit, we can always ask to stop the machine, stop generator, and do the maintenance. So preventive is a waste of time and waste of money, where predictive is an intelligent method. That is possible only through IoT. So that's the role of IoT in maintenance of plant and machinery. I'll show you a beautiful example of that. Predictive maintenance topology with sensors, real-time data. See, machine learning is also involved, and the maintenance specialist gets proper data of before he reaches the site, he knows what to do through the IoT stack. And top floor workers also get the latest information on this. And proceeding, this is the tree for the maintenance architecture, or rather the topology for the predictive maintenance architecture. These are the various devices, the industrial equipment, and these are the field gateways connecting to the cloud. And there is a data processor and a database, and there is a big data warehouse to select the good data. The useful data will be filtered here. It will be filtered here, and certain control applications will be done. With that, the maintenance system engineer can do some automated process of repair, as I told you. And there are various other aspects like machine learning. So next time, this efficiency of the machine can be taken into consideration. So what are the benefits of the IoT in the manufacturing and production? These are the benefits. I'll take it one by one. As I told you, one is the inventory management. Here, the assets, that is where what is at what time and in how much quantity can be known. Okay. Then quality control also I explained how it is. That's maintaining the quality, like the control engineer sitting in Sony and looking at the production quality in China. That is possible. Then enhanced safety. This big data analysis is also possible with IoT. Key performance indicators of health and safety, like the injuries. I told you the heartbeat, higher heartbeat means the person is under tension, in the mine, etc., can be pushed to the stack, and certain preventive and corrective actions can be taken. Predictive maintenance, I already explained what it is and how it is different from plant maintenance. PLA, NAD, that is shutdown maintenance, not required, and we have predictive maintenance. The smart metering is the consumption, that is electric consumption can be known. Like for example, a generator is taking more, or rather motor is taking more current due to insulation damage. Instead of getting a high bill and then crying over it, we can know that there is something wrong by knowing at the consumption graph of electricity and take corrective action. And take preventive and corrective action. The smart packaging, usage patterns, and various handling of products from multiple customers through smart packaging. The tracking mechanisms will be in place, and the product deterioration, that is the shelf life, etc., can be examined by that. And automated workforce management, I explained. Top floor seeing the work of the shop floor by proper sensors placed at vantage locations in the production machinery and belt. And digital industries, like it can transfer information to OEMs, original equipment manufacturers, and to field engineers, and for helping remote monitoring of the plants and machinery. Asset tracking also I explained already. Okay. Then product development, we can make digital twins here. I'll just show a short video on digital twins and come to the end of today's session. I think we are almost on time. I don't. We have. Can I take another 10 minutes? My appointed time is over.
Yes, sir.
And I have another meeting at 7:30. I just want to close by 7:10 to 7:15. Okay.
Okay.
10 more minutes. Are the students happy with another 10 more minutes of valuable information?
Sir.
Arun, are you there?
Yes, sir. Yes.
Yeah, okay, Dr. Ajit. Yeah, you can continue, sir.
Yeah. We are nearing that. Nearing my target. Okay. Now, product development and digital twins. I'll show you how it works. I have a beautiful video on that. And what is a digital twin? It is nothing but a simulation of the actual article or the equipment, so that you don't have to play around opening bolts and opening panels to see what it is. You can just ask the digital twin and it will help you out. That is a part of IoT's role in digital in product development. And see, research laboratories, R&D labs in product development spread across the country or across the world can be united through the IoT stack. Supply chain management is already explained. That is, you can know the progress. Supply chain management, SCM, is just the chain from the supply of raw materials to the finished product ending in the user's market, the end market, client market. So we have client on the right side, and left side we have the raw material suppliers, and we are the manufacturer. Okay. Now digital twins, what it is a virtual replica of physical electronics and instrumentation systems. It is to be used in production engineers to run simulations before they actually build and deploy the device. That is for product development. And with the aid of IoT, manufacturers could potentially create a digital twin of essentially any type of product, which would allow them to detect flaws sooner and predict outcomes more accurately. So what we can do is, without actually building it and saying that, oh, I forgot, this won't work, and then knocking it down, thus costing wastage of time and money, you can use a digital twin to do it for you. It's a conglomeration of AI, machine learning, deep learning, and of course the IoT, the wonderful IoT stack. It's not only used in product development, it is used for maintenance also. And I have a beautiful video generated by an engineer in GE showing that, which I show it to you just now. Higher quality products and systems is possible with the digital twins. Cost saving, obviously. Data collected can be used by the engineers to know how systems can work under various conditions. So with a range of potential applications, we can generate or rather administer the full potential as industry moves from 4 to 5, as it is happening now. Also with the advent of the 5G bandwidth, which is coming up now, and Geo has started experimenting on that in our country itself. Now a small video on digital twins. I'm sure that the students will be happy to see this. This is what is going to happen when you come out. I explained to you how Shyam and me were working in Bucharest Steel Plant 2 decades ago, or 3 decades ago, when for a digital transmitter, for a DPT, a differential pressure transmitter, he has to bring it to the lab. I had to sit with it and see the card open and see all those things. And the instrument, I had to look at various registers of its last visit to the DPT and what happened and what was changed. And I had to look through various books and all. I had to find those books and records first. If it had come before I joined, then I don't have access to it. People don't keep things properly. And you are in a mess. You may be doing some things which you may not have had to do because those things were not the problem areas. With this, I start this beautiful presentation. Please be all ears and all eyes on this. Arun, shall I start it?
Yes, sir. Yes.
Sure.
operator. A change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39. The number of start-stop cycles has increased by 27.5%.
Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing in my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the offline.
Students, you can see that what is happening is a digital twin is talking to the engineer and helping the engineer to find out the problem, and not only helping. There are 3 things involved in this. One is data acquisition, and one is the data presentation of the data acquisition. The twin has taken the data of this rotor, the historical data for the last so many years. It will see as the movie progresses, and then the twin itself gives options. And the third is the implementation. All the 3 are done by the twin, and then it can be replicated on the physical model itself.
App and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating option 2, which is flex start. Thank you.
Okay, good morning. What you saw just now was not a glimpse into the future. This is happening now, today. This is a representation of a D11 steam turbine that's currently running.
I hope I'll stop it now due to lack of time. I'll share this video with you. It is in the open source. It's available in YouTube. I just took it up because it was very much relevant to what I was saying. So what you saw was the revolutionary change, the exponential technological disruption that is happening, and that is waiting for all of you to be absorbed in this. And that is how that thing works, actually, the digital twin. And I'll share the video with you. And now I think I'm now open to questions and discussions for the few minutes which are remaining now. I'm all ears now.
Yes, sir. Sir, actually, I have found the video and I have shared it with them in their WhatsApp group from YouTube.
Beautiful. I have lowered my task actually. Thanks. It's
Uh,
available
sir,
free to view video from GE.
yeah.
It will be a great thing to view at this point of time when we are discussing IoT and related aspects. Thanks for
Sir,
that, Arun. Thanks.
So we have got 2 questions in the chat.
Yeah.
The first one is, sir, can we use IoT in environment impact assessment?
Yeah, of course, we can use that. And that was discussed also, I feel. Like when I was discussing, Arun, about that agriculture thing, no? It was
Yes, sir.
actually had a relation to environment also. How do we protect the environment, Arun, to see that the plants and animals don't decay, don't die away, and greenery is all around. With a little expansion of the IoT in agriculture, we
Yes.
can mitigate the draft effect. The draft, not the draft. The draft is the wind. No, the draft effect. DRAUGST. I mean, that to a great extent, and you know, promote a greener world. And that is one thing, environment. And another thing is, like I told you, the vehicle emission. The vehicle emission through CAN, control area networks, the various sensors in the vehicle, which sense the condition of the oil, the lubricants, and all that. And of course, the catalytic converter, converting and making the emission in compliant with the BS4 or BS6 standards. All that are communicating to the cloud at the factory level in this connected factory, and IoT is playing a role in mitigating that. So through IoT, through the app, uh, a concerned a concerned owner can know that his emission level is high, and even the days are not that far when the emission control board also adopts it, and now nobody cares for the emission control. Now we are not getting caught by that pollution control thing. In very rare cases it gets happened, so most of them avoid that. Going there, they're taking the pain and going there. But through IoT stack, the emission levels can be seen by the emission control board or the environment department and can catch you if you exceed the limits. All these things will bring a kind of mandatory aspect on emission control, which again promotes a greener world.
Okay, sir.
And if I start talking about how IoT will help in promoting a greener world, it may be in 10 o'clock, because there are so many.
Yeah.
I've just explained two only, I don't.
Okay. Okay,
What
sir.
any other
Yeah.
question?
So one more question. It's regarding the personalization experience which IoT can provide. The personalization in IoT, which was explained before, won't it bring privacy concerns since a person's personal preference are saved in a server, which can be accessed by the service provider?
Oh, I can. That person
It
was
was,
talking about the coffee vending
yeah,
machine.
yeah, yeah, coffee vending. It was asked
No,
by
no.
a student, Bharat.
Bharat is there. Can he come on video? I wanted to meet him.
Bharat, are you there?
Yeah, I'm here. I'm here.
Can I see you? Because a nice question. Because nice questions I would like to see and talk.
Hello, sir.
Where are you?
I'm at my home now currently, Trivandrum.
Bharat, I can see you. Yeah, I can see you. Did you attend my last session?
Uh, yeah, I was there in that too. Yeah.
I remember that name, Bharat. Yes, a nice name and nice person. Good question. The thing is, how do you feel that doesn't it improve you? For example, you go to a Cosmopolitan Hospital, there is a smart coffee machine there, and you are already troubled by some patients' health issues.
Yes.
You wanted a coffee
Uh-huh.
of your taste, and you don't want to waste time blending it yourself. And this was since your fourth visit, the system has learned your by heuristics. AI has learned it, and you are
Uh-huh.
having a coffee of your choice. How does it affect your privacy?
The thing is that if the service providers knows my preferences in my like choice in coffee, they could actually sell it to ad like advertisements so that they could target the ads towards me. If they have my details like phone number or email ID or something like that. Basically, I just thought like for example,
Yeah, I know that
Google
thought
looks
process.
at our
Bharat, that thought process is very good. My answers are like this. One,
uh,
there are two types of things now, benign and malignant information. Now, this is only a benign information that the IoT stack is getting from you to make your life easier.
yes.
Okay, and you can always stop any IoT stack using this
Mm-hmm.
by disabling your by enabling DND, do not disturb.
Mm-hmm.
And this is a pretty harmless thing. You should be happy that the
No,
machine
the
has
thing is
recognized
that
you. It
the
happens in
thing,
smart shopping also, Bharat. If you go
yeah,
to I explained to you, a seamless entry into a smart shop, like
yeah.
maybe this Mall of Travancore or something, and
Mm-hmm.
it is guiding you to the app is guiding you to the area where you have been earlier many times. So isn't it easy for you? See the jeans section has changed. That floor has changed from third to fourth. It is automatically guiding you there. How much time of Bharat is saved? Just imagine.
Yeah,
So
that's
that
actually
also that has benign privacy and malignant privacy. So good It's not exactly privacy, it's personalization. Personalization
Yeah.
and privacy are two different things.
Yeah.
And cybersecurity will take care of your that kind of privacy protection, that will they take care. Don't worry, yeah.
Okay.
Don't worry, Bharat. That's a very inquisitive and very involved question.
Thank you, sir.
Great. You are in which year now?
I am actually fourth year.
Fourth
I'm a
year.
fourth
That's
year
why.
student. Yeah.
Good. Good. Any other questions, Arun?
No, sir. Only two questions.
Sorry
Arun
for this.
sir,
Yeah.
Yes.
Yes,
Arun
Bharat.
sir, Anant here.
Yes, sir.
Arun sir, a request to the students to please submit their attendance, because I see that there are 55 participants, but only 38 have submitted the attendance so far.
Okay.
Students, very important, because the certificate processing will happen based on your attendance, right? So you need to share your details so that we can help you to get the certificates across to you. So please, I will keep this link open for another 5 minutes or so for your attendance to come in. While if you have any more questions, you can keep asking to Dr. Ajit. Thanks, Arun.
Yes. Thank you.
Any more questions? I'm open to you. I think all of them either understood or it was beyond them. Whatever it is, I don't. S4 students would definitely appreciate it, and S2 it's an eye opener for them.
Yes, sir.
And there, I think it takes some time to digest it, because I thought of so many things.
Yes,
That's the
sir.
only way yeah. I don't know. You should tell them to rethink, or what should I say?
Yes.
Like visit them in their mind. What all I told. Whatever I told is going to help them in the future, whether they are a civil or mechanical or electrical, electronics or whatever. It's all a interdisciplinary subject, and everybody has a bit of it.
Yes, sir.
Understood. And
Sir,
let
actually,
me.
you have kept it very simple in the application perspective, especially with the analogies and all, like IoT, you compared with the nervous system and AI with electricity. So
Yeah.
that is pretty relatable. I think even for the S2 students, on an application point of view, they got an idea, like wherever in which all places IoT will play a crucial role.
Yeah, actually, in that coffee shop, a coffee blending smart machine also, AI is the electricity. It is running on that. Nervous system is this one, that IoT that connects and makes the thing happen. And the oil is the data that he visited earlier, and what was his preferences and all his data. And Bharat should have appreciated that oil, electricity, and nervous system. And just before we close, I think just 1 minute, half a minute on what is going to happen tomorrow, like a trailer. Tomorrow we are going to begin with IoT in healthcare. Very important. We are also doing a project in that. Some kind of things on that will be discussed. How the IoT is benefited from the patient's point of view, from the hospital's point of view, and from the, of course, doctor's point of view. Then we jump into various beautiful case studies on smart city, two things on smart cities, then one on cloud enabled display, then LoRa and BLE enabled parking, then mobile digital insurance, which will be very, very interesting, and so on and so forth. And maybe I'd be able to bring a junior colleague of mine who's working as the project manager in the smart city project. I'll try. I'm not promising, but I'll give it a good try, so that I hope all of you will be there, and none of them are afraid of the technology. I hope that I'll see all of them tomorrow, and maybe a few more, all of us. That's all I have to say. Thanks, Arun, for the wonderful support you have given
Thank you.
to
Thank you, sir.
me.
Ananta, sir, regarding the attendance, what is the status now?
Yeah, so Arun sir, what I am proposing is that I have circulated the attendance form. If you have any other internal mechanism to capture the attendance, you can please do so. I mean, if that is possible. So what we'll do is that those participants who are attending on both the days, we will be able to process their certificates.
Okay, sir. Okay.
So that is one. And students,
yeah, Ananda, please go ahead.
Yeah. Students, we hope that this session was very, very informative to all of you. And a special thanks to Professor Arun also to have proactively shared the video of the experience that Dr. Ajit was sharing. So now here is the homework for you. This is the homework for you. Okay. All of you have to see that video very clearly. And tomorrow, one of you has to summarize what you understood from that video.
Exactly.
So Dr. Ajit will pick up somebody and he will have to summarize the video for all of us. Okay. It will take probably 2 or 3 minutes, but that's what we want you students to do. Please look at that. This is a very, very important video. This is the way the future of maintenance is going to go through. Right? So this is all coming from our heart, because we have seen the trouble of maintenance. How we used to have trouble. We used to stand on the shop floor and absolutely at loss as to what to do. Okay.
Shyam, do you remember those days, Shyam?
Power plant, turbines, compressors, another thing. But I had a point, Arun sir. See, actually, I would request every student. This is not a normal, like what you call a lecture or something like that. We would like to share experiences and we would like to have your reactions on screen. So if you could leave your videos open, it will be like speaking to you personally, one-on-one. It will help us because we want to make an impact to each one of you. We don't want to give a thing to a general sort of information. So it would be great if you could really, it doesn't matter, we are all sitting at home. None of us are, if you see that even the trainer is not in his formal suits or something. We want to just share our experiences and we would like to have it right in front of you so that we could discuss one-on-one. We could see how you react, what kind of interest are you looking at. It's all a feedback for us also. Like how do we interact with students? This should be as if you are sitting in a classroom directly talking to us. That will be the best way forward for us. That is what my sincere request is. Arun sir.
Very true, very true. Arun sir, you need to tell to the students also from your side. Also, okay.
Yeah.
Somebody from the college telling will be making out of difference. You can say those who start their video will get 5 marks more in their exams.
Yeah. Internal exam, na? I don't know, it's up to you now. Internal exams only, now.
Yeah, sir.
So thanks a lot to all of you. It's been a pleasure, and thanks for stretching yourself for another half an hour for this session. And we certainly look forward for connecting with you again tomorrow. And thanks for being on time. Most importantly, bang at 5 o'clock, we were able to start the session today. Thanks a lot for that. So be there on time tomorrow as well. And we look forward for another exciting session by Dr. Ajit tomorrow. Thanks a lot. And with that, we'll sign off.
Thank you. Thank you, sir.
Good night.
Good night, Arun.